Now, I'm going to use a different color for our step 2, okay, which is over here. All right, remember what's step 2? Step 2, we are going to sub the value of x equal to 0 in all of the expression in step 1, okay, and including this guy as well. All right, so step number 2, when x is equal to 0, okay, we'll start off with ascending powers. So we'll start off with x to the power of 0, which is essentially, f0, okay, f0, which is essentially this. And what is f0? It means it's fx, and then placing the x as value 0, which means we're going to sub in 0 over here, okay, that's the y value. Okay, so what I'm saying is f0 is actually the same as y value when x is equal to 0, okay? So what is the y value when x is equal to 0? It's over here. We're going to sub in the 0 here. So that will give us ln, okay, y equals to ln bracket e to the power of 0 plus 1, okay? And e to the power of 0 is just 1, so we have ln 2, okay? All right, there you have it. That's the value of y when x is equal to 0, okay? And this ln 2 is this guy, f0, all right? Okay, now next up, we're going to find out what is f prime 0, okay? What's f prime 0? F prime 0 corresponds to our dy dx. Okay, so you know what? I'm going to put some notes here so it's actually easier to see. Okay, so this is d2y dx squared. This is d3y dx cubed. All right, so we have just solved this part, right? We figure out what's the value of y when x is equal to 0. Let's figure out what's the value of dy dx when the value of x is equal to 0. So in this case, you could sub in over here, okay? Or we could use this. So our dy dx value, dy dx, would be equal to 1 minus e minus, now when x is equal to 0, we know that y is equal to ln 2. So we can actually place the ln 2 over here, right? So minus ln 2, all right? Now we can simplify this or simply press this into your calculator, okay? And that is going to give us 1/4, all right? Let me double check that. Yeah, no, half, sorry. Okay, it's going to give us half. Okay, just press this in your calculator. I don't have much space, so I'm going to save some workings over there. And the presentation over here is perfectly fine, so we're going to move on, right? Now, next up, let's figure out what's d2y dx squared. So d2y dx squared, okay? And that is the guy over here. So again, we're going to figure out what is e minus y. So that will e minus ln 2. And then we multiply it by the value we have in the previous one, which is dy dx. Okay, we had dy dx equals to half when x equals 0. So that will be multiplying it by half. Again, you can press the calculator for this, and then you will have 1/4 in this case. Okay, let's double check that again. All right. Yeah, it's 1/4. Great. Now we still have one more, which is d3y dx cubed. So d3y dx cubed. Okay, so for this one, it's a little bit longer. Okay, we have e minus y, which is e minus ln 2, times d2y dx squared, which is 1/4. Okay, minus e minus ln 2. Okay, and then, minus ln 2. And then after that, multiply that by half. Okay, dy dx is half squared. I hope you can see that these two terms are the same because half squared is 1/4. So if you were to press a calculator, right, you're actually going to get a 0 for this guy. All right, we have just got our first non-zero term. Why? Because d3y dx cubed, it's here, right, which is the value of f triple prime 0. So if this term is 0, 0 multiplied by x cubed and 3 factorial is going to kill this term. So this is gone. So in that case, so far we have only found 1, 2, 3, the first 3 terms. Okay, the fourth term is actually 0. So in that case, since the question wants us to have the first four non-zero terms, we need the next one, okay? We need the next one. So as a result of that, we got to go back to step 1, okay? And figure out d4y dx to the power 4, okay? Now, as you can see, using the tips and tricks by simplifying and keeping my expressions in terms of y, dy dx, d2y dx square, so on and so forth, it's a lot easier to differentiate them when we get to the higher derivatives, okay? I don't think you want to be dealing with the expression in terms of x, okay, by doing the quotient rule for differentiation. This is d3y dx cubed, so we're gonna differentiate this guy one more time. So it's gonna be longer, but it's not too bad. We'll keep e minus y, and then we'll differentiate this guy, right? So that will give us d3y dx cubed, okay? And then next up, we're gonna switch it around, so it will be a plus d2y dx cubed square, okay, dx square, and then we differentiate e minus y, which is going to give us e minus y, and then you chain this, so we have a negative 1, okay, and then after that you need to multiply that by a dy dx, okay, right, implicit differentiation. And then after that, for the next term, which is this guy, right, it's going to be minus, all right, over here, and then again we're going to keep the e minus y, okay, and we're going to differentiate this one, which will be, now you can treat this as a function, okay? So like, for example, ax plus b square, okay? It works the same way, so you're going to power this down. So after that, you're going to do the chain rule, okay? So over here, you're going to power down the 2, so that will give me a 2, okay? And then after that, a dy dx, all right? And then after that, we're going to chain on the inside. When we chain that, it's going to give us d2y dx square. Okay? Have a good look at that again. So we keep this term, we differentiate this, we power down, so it's 2 times dy dx, we decrease the power to 1, and then after that, we do the chain, okay, which is to differentiate the inside, right? When we differentiate dy dx, it's just going to give us d2y dx square. Okay? Now, after that, not to forget that we need to do the other way around. Okay, so we've just done the first part for this one. We're going to do the other way around. So I don't have space, I'm going to write it in the next row. So dy dx square, okay? And then I'm going to differentiate this guy, which is e minus y. So again, e minus y, and then we are going to chain this, which will give me a minus 1. Okay, minus 1. So it's just going to be minus. And then dot dy dx for the implicit differentiation. And then you could simplify this a little bit. I think there are some terms that we can actually simplify a little bit, okay, before we do the substitution, because I'm seeing something here, all right? Look at this, okay? We got a d2y dx square, which is e minus y dy dx, right? So we got this one, which is e minus y dy dx, so we can actually simplify this guy. And then at the same time, we have the 2, okay, omitting the 2, we have this guy and this guy, which is also the d2y dx square. And then over here as well, okay? So I think we can simplify this a little bit more, and you make our life a little bit easier, okay? So this one doesn't change, so we have e minus y d3y dx cubed, d3y dx cubed, okay? And then this one, right, as I've mentioned, this is e minus y dy dx, it's over here. So that is just d2y dx square. So we have a d2y dx square multiplied by a d2y dx square, so that gives us d2y dx square whole thing square. Okay, so this is done. Next up, we're going to have a minus. Okay, so we expand this a little bit as well. So we're going to remove the square brackets. We have a 2. Okay, so we're going to write a 2 here. And then this guy times this guy, again, is the d2y dx square. So multiply by another d2y dx square, that's going to give us 2 times d2y dx square whole thing square. Nice. Now, next up, we have a negative times a negative. Okay, so that is going to be a positive. And then this one again. All right, so that will be dy dx whole thing square. times this, which is d2y dx squared. Nice. And then again, we can simplify this further because, again, I'm going to write it over here. Okay, I'm running out of space, but it should be enough. Because this term and this term are like terms, so we can combine this together, and we have e minus y, right? d3y dx cubed minus 3 bracket d2y dx square, close bracket, square. Then plus bracket dy dx, whole thing square, times d2y dx square. Okay, so that's our expression. Okay, we're going to move on to step 2 to go figure out what is our value of d4y dx4 when x is equal to 0. Okay, so first off, we know that this term, d3y dx cubed, okay, as you can see, is 0. So when we substitute it in, this term is gone, right? So all we have, okay, for d4y dx to the power of 4, it's the ones at the back. So it's going to be minus 3 times d2y dx square, okay, which is d2y dx square, which is 1/4. Okay, and then we're going to square this, okay, square, and then plus half square, okay, that's the dy dx value, okay, square it, then multiply it by d2y dx square, which is 1/4. So let's go ahead and press our calculator and figure out what this value is. So we're going to have minus 1/8. Okay,